All right, we're going to go ahead and finish the first one. We only have 2 more problems left on this, and then we'll start on the second one. And I'll do like I did yesterday, where it's kind of sporadic. I'll go skip questions to go through. All right, it says a company makes and boxes spaghetti. Let me minimize this so you guys can see. One machine fills each box with approximately 32 ounces of spaghetti. After the boxes are filled, another machine weighs each box. A box is discarded if the weight of the box differs by more than 0.25 ounce from the target weight of 32 ounces. Which inequality can be used to find the range of acceptable weights X of the spaghetti? So when we're looking at this, it says one machine fills each box with approximately 32 ounces of spaghetti. So we definitely want the 32 ounces. Can it vary from 32? Yes. So that's what tells you where the 32 goes. So because it can vary from 32, it's not going to be equal or less than or equal or greater than. It could be exactly 32. It could be a little bit above and a little bit below. Does everybody understand that? So that tells you that the 32 has to go on the inside because that's the one that varies. And then the question is it minus 32 or plus 32? So which one do you think it is? Which one do y'all think? Oh, talk to me. Come on. What? Why is it minus? What word in the problem tells you that it's minus? What's this right here? Differs means what? Subtract or difference. Okay. So it's actually going to be C on this one. Okay. Again, make sure you're writing it down because what you'll have is another drop box today to turn into. All right. The last one on here that we haven't done is number 9. These are work problems. They're all worked out the same exact way. And I don't do a whole unit on these because they're worked out the same exact way the whole time. So it says Martha can paint a room in 2 hours and Jamie can paint the same room in 6 hours. How long to the nearest 10th of an hour will it take them to paint the room? So it says Martha can paint it in 2 hours. So the way you're going to set it up is X over 2. They're going to work together. Sorry, that should be a 6. Jamie can paint it in 6 hours. And then they can do one full job together. Okay. So you'll always set it up like this. Whatever hours they paint in separately, add them together, and then it's always equal to the one job that they're doing. All right. So then to add these up or to solve this, we have to have common denominators. So what would my common denominator be? You can do 6. Is everybody good with that? What do you say? It's got to be big. So it's going to be 6, or you can do 12 or anything that's multiples of 2. It doesn't matter. Y'all understand that, right? All right. So you can use 6. That means I have to multiply this by 3 to get 6. So I'd have to multiply this one. And then this doesn't have a denominator, so it needs the full 6. Okay. So then your denominators do not matter. You have 3x plus x equals 6. 3x plus x is 4x, and then divide by 4. And you can reduce it to 3/2 or 1.5. So together it will take them 1.5. And here, watch these, because this is a fill-in. It said the nearest 10th of an hour, so they definitely want it in decimals. Okay, so don't put it in a fraction. Make sure you put it in decimals. If they don't specify, you can use any of them. Okay. Any questions on this first part? Is everybody good? All right, we're going to jump to the second one and check it out. I'm going to go to number 19. Remember what I told you, these like this? I'm going to stop sharing for a minute. Put in Desmos. And then share this Desmos screen with you guys. Anything that's equal to, so this one was 9 to the negative 3x minus 2 equals 48. I would put 1 in y1 and 1 in y2. You may have to put y equals in. I don't know. We'll see how it works. 9, let me get in there. 9 to the Negative 3x, if you don't do the parentheses, it might bring it down. So, and then in the other one was 48. Now, you're not going to see the 48 because we only go to 6. So I'm going to minimize it. Try to get to the 48. See how you don't see it? If you can't see it, sometimes it does. Like the other day we did just fine. Or yesterday we did just fine. If it won't do it, just put y equals in front of it, okay? Sometimes it will, sometimes it won't. And then we're looking for that dot right there where they cross. So I'm gonna zoom it in so I can see it a little bit better. There it is. So 0.79. So what's your answer? A. Okay. If you have to, zoom in a lot so that you can see where the two, see how you can barely see. There you go. Now you can see the actual intersection, and that'll help you out a lot. So you guys can see that, but you'll have to manipulate. Now, once you manipulate it, just so you know about Desmos, if you hit home, it'll center it back up and go back to regular. So like with your calculator, you have to do crazy stuff, but with this one, it's just really quick, hit home. All right. I'm gonna flip through. I'm gonna stay on Desmos for a minute because I'm gonna try to do mostly everything on Desmos. If I can, go ahead and get that done. Might not be anymore. All right, let's look at number 17. We'll go backwards to number 17. So 17 asks you, what is the distance to the nearest hundredth of a unit between the two zeros that are closest to each other? So remember what we talked about with zeros. If you need to, put in y equals 4x to the third minus 5x squared minus 23x plus 6. All right. So you guys see that there are different zeros, right? I'm going to write those 3 zeros down. So we had -2, we had 2.5, and we had 3. I'm going to close this out. I'm going to stop sharing here. And I'm going to go back to my paper. All right. So what is the distance to the nearest hundredth of a unit between the two zeros that are closest to each other? So on a number line, it's going to be either these two or these two. On a number line, how far away are these from each other? -2 to 2.5. 4.5. How far is 2.5 to 3? So what's your answer? That's it. So the closest one is this one. Was it 0.25? Yeah. Yell at me next time. Hold on, I'll go back and look. Thank you. If absolutely, if it's wrong. And that might be why it says the 100th. Sorry. It is 0.25. I just can't see. We'll fix it. Sorry, y'all. Thank you. I'm sorry. Still working the same way. All right, so 0.25. So -2 to 0.25 is going to be 2.25. Is everybody okay with that? -2 to 0 is 2 units and then 0.25 more. And then 0.25 to 3. Say it again. So now which one's the closest? There you go. Sorry, y'all. Always correct me. Any questions on 17? I think that's about the last one we can use with Desmos. Need to go over unit circle. All right, so let's look at this one. I'm going to graph this for you. Remember, you guys get graph paper too, so it's real easy. Let me turn it the other way. All right. So we have the coordinates 0, 0, 1, 2, 3, 4, 5, 6, 3, 6, 7, 8, 9, 1, 2, 3. This is the vertices of a triangle are at 0, 0, 6, 6, and 9, 3. What is the volume in cubic units of the figure created by rotating the triangle about y equals x? Y equals x. Is going to go right, and I didn't draw my line very straight, is going to go right through there. So if I rotate that, if I spin a triangle, what figure am I going to make? Think about it. Spinning a triangle. What solid figure would it make? Think about if I put like some ink or something on the corner, the outside corner, not the middle corner, but the outside corner, and I spun that triangle. What shape is it going to make? A circle. So the base is going to be a circle. What's going to happen at the top? What's going to be at the top of this figure? Think about that triangle and holding it. Think about holding a football or something like that. What's at the top? A point. So what has a circle at the bottom and a point at the top? A cone. Okay, so sometimes they'll throw something like that in there. Okay, if you rotate a prism, like a rectangular prism or a square prism, that's going to give you a cylinder. Does everybody understand that? Okay, so think about that if you have to do that. So we have a cone. We went through our volume formulas. If it has a point, it's always 1/3. And big BH and big B stands for area of the base. Area of the base. So you told me that the base was a circle, right? So area of a circle is pi r squared h. H is part of the volume formula. Okay, so pi r squared is the area of a circle. All right. So now all we need to know is the height of this triangle and the base or the base area of the radius. So if you guys look, this part right here will be the height. How do I figure out what that is? You got to go back to math 1. This is where math 3 is not good. Okay, so it tests everything in math 1 and math 2 as well. So we're talking about the distance formula. If you don't remember the distance formula, it's okay because I don't teach the distance formula. So if you had me, you never learned the distance formula. What you did learn was Pythagorean theorem. Okay, you guys remember Pythagorean theorem? What is Pythagorean theorem? A squared plus B squared equals C squared. So I'm going to figure out the height of this thing by doing Pythagorean theorem with that blue triangle right there. Okay, so I want to figure out this H right here, this height. So I have 1, 2, 3, 4, 5, 6 for my A. 1, 2, 3, 4, 5, 6 for my B. So I'm going to do Pythagorean theorem. 6 squared plus 6 squared is going to give me my height squared. I get 72 equals my height squared. And then remember, I just take the square root. Right now, I'm going to leave it as the square root of 72. I'm just going to leave it as that for a minute. Okay. Then I have to do the same thing. If you guys think about it and we rotate from the center of the circle to the outside is the radius. So this part is going to be my radius. It is 3 and 3. So 3 squared, that should be a square. Plus 3 squared equals r squared. I get 18 equals r squared. And then again, I'm just going to leave it as a square root. All right. Now I just need to put it into my formula. All right, so I'm going to pull this up. We said that h was the square root of 72. R was the square root of 18. In our formula, 1/3, I'm going to leave pi in there. R was the square root of 18 squared. H was the square root of 72. There's a couple different ways that you can do this. I'm kind of lazy, and that's okay. And I'll tell you that all the time, okay? Especially if it's multiple choice, I get real lazy. So I'm going to go ahead and put this in and get my decimal. I will do it a different way in a minute, but I just want to show you. 1/3 pi square root of 18 squared square root of 72. And I'm going to get my decimal because, like I said, I'm kind of lazy. So 159.94. And those aren't in decimals, but I can plug them into my calculator and get those decimals. So if you look at your answers, 54 square root 2, did I get that number? No. 324 square root 2, did I get that number? No. 36 pi square root 2, did I get that number? Yes, I did. Check the last one just in case I put something in wrong, and I will always tell you to do that. I don't know what I just did. 108. Sorry. Pi square root 2. 479, so we know it's not that one. Now, how did they get this? They just cleaned this up. So they got, I'm going to work it out for you so you guys can see it. Those of you that like to do it by hand. Square roots and squares cancel out, so we just have 18, and then we have the square root of 72. 18 divided by 3 is 6 pi. Can y'all start seeing why I don't like to do this by hand? Your factors of 72 are 9 times 8, which break into 3, 2, and 2. I have a pair of 3s, a pair of 2s. So that means I have 6 pi, 3 times 2 is 6, square root 2. 6 times 6 is 36 pi, square root 2. You can do it by hand. By why? Y'all see what I'm saying? Okay, so you choose whatever you want to do. I don't mind either way. All right. Any questions on that one? That one's probably one of your harder ones you're going to get, only because it tests Math 2, those 3D figures, and your formulas for volume, and then it also tests your distance formula. So it's a lot of stuff going on in there. All right. This one's kind of easy. This is Math 2. This is Math 2. In parallelogram, MNPT, what's a parallelogram? You got to be able to know what they are. What's a parallelogram? Nobody knows what it looks like? Whew, you better study your shapes. You better study your shapes. Parallelogram is a pushed over rectangle. It can be a rectangle. It doesn't matter. When you label it, just go around in a circle. MNPT. It says angle M is 6x plus 10, and angle N is 5x plus 10.5. All right, so you may not see this, but I'm going to make you see it. These two in these figures are either going to be equal or they're going to add to 180. We've already talked about this before when we were talking about our triangles and circles and stuff just a few weeks ago. Okay, so let me show you. Have you ever seen anything that looks like this pink line? Two parallels cut by transversal. That's math too. Does everybody understand that? Okay, so we got to think back to that. In parallel lines cut by a transversal, just to teach this for you guys. Remember x's, we talked about x's were equal, right? Okay, so these are equal. These two will be equal. If they're in the same position, so this one is underneath the first parallel line. This one is also underneath and diagonal. Those will be the same. This one is on top. So those two will be the same. Okay. So let me make it a little more visual for you. All of the blue ones, I didn't do that right. All of the blue ones are the same. All of the green ones will be the same. But we're not talking about either of those with diagonals. We're talking about these two. Are they equal? No, because they're different colors, right? So they're definitely not equal. So the only other choice we have is that they equal 180. So they will add together and equal 180. So that's what we're going to do with these two up here. You're going to take your 6x plus 10, add it to your 5x plus 10.5, and set it equal to 180. Six x plus 5x is 11x. 10 plus 10.5, that should be a plus, is 20.5. How do you solve? You're going to subtract 20.5. You get 11x equals 159.5. And then we divide by 11. Did it ask you to solve for x though? This is another way they trick you. What do they ask? Okay, so if we look at angle T right here, what do we know about T? What do you think? One of two things. You can give me one of two answers. How could I find it? So what? Yeah, it's equal to n, or what about these two? They equal 180. Doesn't matter how you solve it, whichever one you remember is perfect. So these two are equal. So we can do 5x plus 10.5, plug in that 14.5. So 5 times 14.5 plus 10.5 is 83. Is everybody good? So again, see where it's testing math 1, math 2, and math 3. All right. Check this one out. Kind of the same thing. This is math 2 as well. In rectangle FGHI, diagonals FH and GI intersect at E. If it is a rectangle, what do you know about all of these parts, these lines? They're all the same. So everybody understand that? So all of these are the exact same length. So it says IE is 3x plus 4. EG is 5x minus 6. It wants the length of FH, but it doesn't matter. As soon as we find one of them, we can find that full length, okay? So this one is going to be the same as that one. So these two you said were equal. So that's what we're going to do, equal 5x minus 6 We're going to subtract 3x. We get 4 equals 2x minus 6. We're going to add 6. We get 10 equals 2x. And x equals 5. Please don't put 5. Are you doing the problem correctly if you put 5? Yes, you are, but it's not the right answer. What do they want to know? The length of F to H. So all we need to know is one of these lengths. So what is 3 times 5? Plus 4. So this one is also going to be 19. So how long is the full line? What's 19 plus 19? 38. So just watch what they ask for. Again, not hard work. Just ask for a million different things. Okay. If you were solving for X, the problem would have been done a while ago. All right. Let's keep looking. All right. 26. We just did these. It's asking about the length of the radius of the circle represented by the equation, but we have to get it in center radius form, standard form. Everybody got it? Or I'm sorry, vertex form. So on this one, we got to get our x's together, our y's together, put our blanks in and finish it out. And then we can find our radius because right now it doesn't show the radius. So we're going to put our x's together and put our blank in. Put our y's together. Put our blanks in. Subtract your 4. Put your blanks in. How do I fill in the blanks? How do I fill in that first one? How do I fill in that first blank right there? And you don't even have to put the negative on there. You can just put a regular 4 divided by 2 is 2. And then what do I have to do to it? Not times 2, but square it. Perfect. What goes in one side goes in the other. The other one is the same exact one. So we're going to go ahead and put that in there. Rewrite it. Remember, we do the square root of the first, the sine of the first, and the square root of the last. So x minus 2 squared. We're going to put a plus. Same thing, square root, sine, square root. And then clean this up. A negative 4 and a positive 4 cancel out, and we just have 4. Remember that this last number is the radius squared. It is not the radius. So the radius squared is 4. How do I find the actual radius? Square root of, what's the square root of 4? Perfect. So your answer on this one should have been 2. (28) is from Math 1, but it's common sense. Okay, so 28. It says, which method is most likely to produce a random sample of 5 students from a school club? Random sample. Selecting 5 club members who have brown hair, selecting the 5 club members who have raised the most funds, selecting 5 club members from a hat containing the names of all members, or selecting the 5 club members who arrived last to a club meeting. See, you want to pick from all of them. You can just put them anywhere, it doesn't matter. Thank you. Is everybody good? Pretty simple. All right. Thank you. This because I think there's more somewhere. They're probably in a trash bag or a bucket or something. All right, sorry, y'all. High school randomly selected 75 of the 200 seniors at the school to take a sample college entrance exam. The mean GPA for the seniors was 2.85 and the standard deviation was 0.4. All of the statements are true. Click on them. So it says the margin of error, it gives you a formula. It tells you what S and N stand for. S is the standard deviation and N is the sample size. Both of those are given to you. Okay, so we're going to go ahead and work on that. So we're going to start with your margin of error equals 2 times S over the square root of n. What was your standard deviation? What did they tell you? Read your problem. Guys, read it. Come on, answer. Thank you. What's your sample size? How many people took a survey? 200. We're going to put that in our calculator. And we get our margin of error is 0.056. All right, so it says click all that apply. So we're going to start here. So which one applies? The first one, right? Will the second one apply? No. Okay. So then the third and fourth says the margin of error would decrease, or the other one says increase, if the sample size were changed to 125. So if we change it to 125, I'm just going to redo this. Change this to 125. I get 0.07. What happened between these two? It increased. So the only choice would be this one. That's all you have to do. It's real simple. They gave you the formula. They gave you the stuff in there. You didn't even have to find anything. Plug it in. All right. Yes.
Why would you not use the 75 for the first one when you put 200?
All right. So your sample size, oh, maybe you are right. You are right. You are right. No, I just looked at the 200. No, you are right. Why'd you make me do the whole problem before you did that? So it's going to be the opposite too then. I'm going to tell you that right now. No, my mind is elsewhere. I'm sorry. This is my problem. Square root 75. You are correct. 200 is your population. 75 is your sample size. So I apologize. But thank you for telling me. Next time, yell at me way sooner. And like I said, it never hurts my feelings. So that's what I told you. It would just change both of them. All right. And then if I change it to 125, it goes to 0.7, like we said, so it would decrease. So I apologize. It's the two that we said it wouldn't be. And not these two. Sorry. Yell at me louder next time. All right, let me keep looking. This one is pretty much the same. It says which choice would decrease the margin of error. So there's your margin of error. Again, the same formula. Your S is your standard deviation. So if you look up here, here's your S. And N is the sample size, a random sample of 100 drivers. So there's your N. All right. So 2 times 2.5 over square root 100. Square root 100. You could have put 10 there. It doesn't matter. Gives me 0.5. Okay, so that's the one we're basing it off of. Which choice would decrease? So we want it to be less. It says decreasing the sample size. So I'm going to take this, and you can put it to anything. I'm going to just change it to 10. I'm going to make it really little. Did that decrease it or increase it? 0.5 to 1.5. Increased. So that didn't work. Increasing the sample size. So instead of 100, let's do 200. It went to 0.3. What happened? That's it. Once you get that answer, go on. Changing the time that the data is collected is not going to change anything. It may just take you longer to get 100 or less time to get 100. So if it's like rush hour traffic, it would take you less time to get 100. It's not going to change the margin of error. And then changing the road is the same thing. It might be a road less traveled. Got it? All right. So what I'm going to do is stop there, and we will finish the rest of it on Monday. And then on Tuesday and Wednesday, you'll probably get a new set of stuff. Got it? Is everybody good? All right. So I'm going to stop sharing, stop recording.